Bus Consortium first. We'll pause, take some questions, and then we'll kind of move on from there. We'll see how the time is doing. So I do want to start with some acknowledgments. First of all, from AACOM, I want to talk about some of the staff that have been involved with the Automated Bus Consortium program. So Dick Wolsfeld, he's one of our executive VPs for the company, and he's the Automated Bus Consortium, or ABC, program director. And he was really the mastermind behind the concept and started promoting it, and took a lot of effort in getting it initiated. So want to thank Dick for everything he's done. I also noticed Gene Roostman from the Michigan DOT Office of Passenger Transportation is logged in, and Gene has been instrumental and a great leader in the program, very vocal and participating in our policy committee and other meeting activities. So I want to thank Jean for everything she has done for the program. Janet Giesler works with Jean, and Janet has been very active in the program, as well as some of their other staff. Michigan DOT, I'll talk about the pilots. They partnered with CATA and MSU on a couple of pilot routes, and also Huron Transit Corporation in the Thumb area of the state. And so we've been working with Matt Odsema and Kai Christensen from CATA, Dr. Wolfgang Bauer from MSU, and Ken Jimkowski from Huron Transit. Another partner has been Planet M, and Charlie Tyson has been involved, as well as Amanda Roraff, and they really helped us out with the industry forum that we conducted last year in Detroit. I know Amanda's moved on to a different position, and Charlie's more active with the program now. Locally from AACOM, Jeremy Windsor and Whitney Sherrill have been pretty active out of our Southfield, Michigan office. So with that, I'm going to go ahead and get into the program. So this is kind of how the concept started. AACOM, we've been doing some work with a variety of the small AV shuttle vendors. And, you know, on some of our projects, we started talking to them. You know, if you look at the larger full-size buses, there's like 80 to 85,000 of them throughout the U.S. market. We said, you know, that would be a great business model. Can you take the technology on the AV shuttle and move it to a full-size bus? And they said, yeah, we can do it, but we just don't have a market there. And when you start asking, well, what do you mean about a market? What size of an order would you need? And they came out with the number 75 to 100. And so as we started thinking more about this concept and talking to transit agencies, no one transit agency could do an order of 100 buses, because you're talking about like $100 million bus order. So then we started kicking around the idea, well, what if we formed a consortium of agencies that could do the procurement together, and then you could split that order amongst a variety of agencies. So that concept started getting promoted amongst various DOT and transit agencies throughout the country, and there seemed to be interest, so we continued to move forward. So our goal with the program is to deploy full-size, full-speed accessible level 4 automated buses. And we wanted the consortium to have a variety of agencies, a variety of climates and geographies, and we wanted to do a variety of applications. We didn't want each agency doing the same thing. So that was kind of a goal going into it, and that was something we considered as we finalized up what the pilot projects were going to be. We did formulate a bus spec committee, which included membership from each of the agencies, and they considered the vehicle propulsion systems, and pretty much at the start they all agreed that the battery electric buses were the way to go with the automated bus program. So we did select that as our propulsion system. And a lot of you are probably familiar with the Society of Automotive Engineers and NHTSA's levels of automation. So again, we're looking at level 4, which is the high automation. We're still going to have a steering wheel and pedals in the bus. We're going to conduct our pilots with an ambassador on board. we're always going to have an individual, that driver in the driver's seat, ready to take over control, or may need to do manual control on portions of the route initially. So that's the level we're looking at. And when you start thinking about an automated bus and what it needs to do, so, it needs to recognize the environment it is in. It needs to recognize traffic signals. Is it red? Is it green? It needs to be able to detect other vehicles that are at the intersection, pedestrians, bicycles, scooters, skateboards, just a lot of different activity, right? So then the trick is, how do we spec out a bus to be able to perform in all the different environments it's going to be exposed to? And I'm going to, later in the presentation, I'll talk about our bus specification and kind of our approach to doing that. I'll also show you some of the operational design domains that we came up with each of the pilots. So why automation? Here's a list of the challenges and the benefits of automated technology. When we started approaching the transit and DOT agencies, it was really about reducing those operating costs and, addressing the driver shortages. That's been a big issue. And a couple other things really came out as high priorities. And number one is kind of the safety. They wanted their buses to be as safe as possible for the drivers and the riders. The other thing was really improving that rider experience, coming up with a more contemporary type of bus that would raise the attractiveness of that service to the public. So those were a couple other higher priorities that came out. So as we got into it, we wanted to kind of do a little assessment. Can the vendors actually produce the desired bus that we want? And so if you start looking at, again, the AV shuttle industry, right? Roughly 260 worldwide demonstrations going on. The number's probably higher right now. So a lot of activity initially in Europe and other parts of the world. In more recent years, we've been seeing a lot of activity here in the US. There's a few examples listed here. Las Vegas was probably one of the first to actually put an AV shuttle on a public road and operate it. Minnesota, I'm going to talk more about that if we have time later, but they really wanted to focus on the winter weather testing aspect of it. And then Columbus has been doing quite a bit under the Smart City program. And right now, this is actually an image of the AV shuttle they have, which is, I believe, running from like downtown to a southern neighborhood and providing service right now. So the smaller AV shuttles have been great for the industry, right? It's exposed the technology to the public. It's kind of refreshed that image of transit. It's proven that automated electric buses do work, but we also recognize there are some limitations. The speed is a big thing. Right now, if they're put into operation in an automated mode, you're operating on average around 11 to 17 miles per hour top speed. And the amount of passengers you can carry is really limited too. So that seems to be driving the need to go to a larger bus with a higher speed. So then you start looking at the full-size buses and what's happening there. You've got activity going on internationally. So these images here are actually from China, Singapore, and Scotland. So they're all starting to test these full-size buses and putting the technology there. Most of them are still kind of operating at the slower speed, but the speed keeps getting pushed through software updates. The thing that's happening here now in the US is we've had a lot of discussions with the bus manufacturers. They're working on level 4 automated buses, and now we see them forming partnerships with the technology companies. And, so there's a lot of interest there here in the US to actually starting to make this a reality. We also know there's a lot of money being dumped into automated vehicle technology by the auto industry and venture capitalists. This is dated, this information, but you can kind of see this Brookings Institute report. I think they published it in 2018, but they looked at that 3-year period from 2014 to 2017, and $80 billion was invested. And we keep hearing about automated vehicle technology every day in the news. So our conclusions on our assessment was we realized there's significant investment being made in the industry. From what we are hearing and see, they appear to be able to produce a level 4 full-size, full-speed, accessible bus by the kind of the 2023 timeframe, but they need a market to do it. We've heard a lot about labor as a concern. I'll talk a little bit more about that. And then FTA, we've been fortunate to have them involved with the program. We've had their participation in some of our policy committee meetings. They've definitely expressed interest in what we're doing, so that's a good thing. So we did conclude that it seemed like we were on the right track, so let's continue to move on with the program. So these are the agencies that participated in what we called our phase 1, the feasibility study. Nice mix of agencies. We've got large transit agencies. We've got departments of transportation. We've got kind of mid-sized transit agencies, very small. Michigan DOT, I already mentioned. They had partnered with CATA, MSU, and Huron Transit. And the process MDOT took was putting out a solicitation to the transit agencies within the state. I think they got like 5 or 6 proposals back, and then narrowed it down to the 2 partners. Department of Rail and Public Transportation is from Virginia. They partnered with Hampton Roads Transit, kind of a medium-sized. Minnesota DOT partnered with Rochester Public Transit, which is a very small agency. We have very large transit agencies like LA Metro, MARTA, DART, Houston Metro, and then some of the other mid-sizes like Long Beach Transit, Foothill, and then PSTA in the St. Petersburg, Florida area. So that shows you who our consortium members are. And this really just shows some of the potential value of the consortium coming together. A big one is we want to learn lessons from each other. So again, the variety of geographies and applications and trying to do different things and testing out different capabilities is going to allow us to share lessons with one another. Another big one is this reduced planning and procurement costs. So let's just say, for example, we spend $250,000 on a bus spec. So instead of one agency paying for that, we have the ability to divide that by 12 agencies. So you can see some nice cost efficiencies there. So we, did consider the risks for the program and did create a pretty detailed risk register. I think we've got like 20 on the list right now, kind of identifying the likelihood of it occurring, the severity, what would be some mitigation measures. So we've been monitoring that over the past year. Some of the big things are, is this going to be accepted by the riders? Can the technology companies actually deliver what we're asking for? And what will be the real cost of that? Are the agencies going to be able to afford it? And the labor opposition we've seen and kind of keeps coming up. And a great thing that's happening right now is the Transit Cooperative Research Program. They put out a solicitation recently and hired Texas Transportation Institute to look at the effects of automation on public transportation workforce. So it's great that that's being looked at by TTI. And they did a recent webinar, so I pulled a few slides from there. So one of the things they're looking at is the types of jobs that are directly impacted by automation, such as the operators, mechanics, maintenance technicians, fuelers, cleaners, and so on. But also, what types of positions would be indirectly impacted, like the superintendents, the trainers, operations and maintenance facility maintainers, and things like that. So they're kind of doing this quantitative and qualitative assessment on those impacts. The good thing is, with the technology, we're creating a new workforce, new jobs, and new opportunities. And this is 4 bullets that kind of list what some of those opportunities are coming up with automation technicians, electrical technicians, and so on. The other thing, with our initial pilot with ABC, we are not going to be removing the driver. So that person is still going to be on board. You know, once the automation settles in, proves itself, maybe that driver becomes an ambassador, right? So you could focus more on customer service. When we ultimately get to a situation where they're self-driving, we do not need anybody on that bus. Maybe the ambassador is situated in a remote control center somewhere monitoring this fleet of automated buses out there. So now we're freeing up several drivers, right, which could actually be placed into traditional buses. So that gives the agency opportunities to expand their bus service to other parts of their jurisdiction. So we're going to be monitoring what happens here under this project, and it's going to be great information for us to learn from. So this automated bus consortium, the ABC, we are approaching it this way. So we broke it down into a couple phases. Phase one is the feasibility phase, and that's really what we've been focusing on for the last year or so. Some of the key activities were really identifying what are those pilot projects for each of the agencies. So we went through exercises with them to determine their top pilot. We looked at kind of where are the agencies related to electric charging, what's the regulatory situation in each of the states, kind of what's the deployment strategy. And so we put together all of our findings into a report, and that was submitted to each of the agencies this past spring. Right now, the agencies are going through what we're calling a go, no-go decision. So that kind of started in early July, and we figure by the end of next month, we'll have a solid feel for which agencies have made a determination that, yes, we want to move forward with this program and participate in our next phase, which we're calling phase 2A. And that's going to be really focusing on the bus procurement piece of it. So we would finalize up the procurement package, put it out to bid, get proposals in, go through the evaluation and award process. We'd work out the details related to the testing plan and how we're going to conduct testing, determine what the specific electric charging requirements are for each of the agencies, and then any regulatory clearances that have to happen, we would make sure that process moves forward. And then really after we get the bids back from the bus manufacturers, we'll know what the exact price is of the buses. We'll also know what the cost is going to be for electric charging infrastructure, and the agencies are going to be able to make a kind of a final go, no-go decision. Do I want to be part of that procurement or not? And so we're going to be asking each agencies, are you in or are you out? And then we'll have a final order and we'll know the exact number of buses we want to procure, and then we can start moving forward with the phase 2B, which is the deployment and actually conducting the pilots and doing the evaluation. So the structure of the consortium, we formed a policy committee, includes membership from each of the agencies that are participating, kind of CEO, general manager level, high senior management individuals are participating in that, really setting the direction for the program and helping us establish some of the policies we need to address. And then we have several technical committees we formed, planning and ops, the communications, and the specifications procurement committee. And again, each of those committees have representation from each of the agencies. So AECOM's role is really kind of more of a program management and facilitating the meetings and discussion that needs to happen. So I'm going to spend some time on the pilot projects right now. So what we did, we went through an exercise with each of the agencies to determine, well, what do you want to do? What's the need? And so what we did was we looked at roadway characteristics, bus route characteristics, and some external things. And some of the agencies came up with like, well, I've got these 6 candidate potential routes or ideas that we'd like to implement. So we went through an exercise with them and we tried to narrow the 6 down to 3. And then ultimately we wanted to get down to 1. One of the things we looked at was the complexity level. How complex would it be to actually run an automated bus on this route? So that came into consideration as we did it. So when it all was said and done, this is actually a matrix showing the top pilot for each of the agencies. So you can see the agency on the left-hand column there, and the types of applications on the top row. Again, remember, we wanted a variety, and it actually worked out really nice. The only column here is the BRT mixed traffic, but some of the agencies chose routes that they're discussing implementing future BRT. So that column will actually be filled in the coming years. But we have a nice mix of applications, BRT in exclusive lanes, in hot lanes on the freeway, and mixed flow freeway situations, arterial operations. I'll talk about the shuttle types of services that got proposed in Michigan. And then a couple of the agencies actually wanted to do yard depot operations. So I'm going to spend some time going through samples of the pilots. So we're going to start with Michigan. So this example here is one of the routes, Route 32. It's actually on the Michigan State University campus. And I think that the main thing here is that it's a shuttle type of service. It's going to be the full-size buses, right? But it basically is providing the service to the students on campus. There's a couple large park and ride lots that the bus is going to be serving, one on the south end there, and then one on the east end here. And basically, this is the route that got identified. And I talked about complexity, right? That's one of the things we wanted to consider. So AECOM actually created a tool that incorporates GIS shapefiles. We've got all the roadway geometry, traffic signals, stop signs. We put in lat longs, and we also put in elevation. And we wanted the tool to kind of help us identify what are those complex areas. And this is related to automation. And the other thing the tool is going to be able to be used for is actually taking a look at the impacts to the batteries for the electric buses. So based on kind of the distance, how the bus operates, the elevation changes, we'll be able to determine the draw upon the battery and to see if that's a consideration or a concern for the agencies. So I think the complexity here on this Route 32 is really some of the tight right turns, and most of it is kind of listed as a medium complexity, and that's really because of the high level of pedestrian activity on campus. So Route 38 is another route on campus, and this is really, serving the Spartan Stadium, the Spartan Village. It makes the connection into the Amtrak station there. And the complexity may be a little bit better here. But again, I think it's where you're maybe making some left turns, or some of those tight turns is where the higher complexity comes in. So this is Huron Transit Corporation's pilot. And I think, you're probably familiar, they're located in Bad Axe, Michigan there in the Thumb area. So this is an interesting story. So there was I believe it was Hurricane Maria in 2017 that really devastated Puerto Rico. And there was a big displacement of individuals and the citizens there and workers. So there's a Blue Diamond Steel casting plant located here in Pigeon, and they actually started a program to recruit workers. And so they got a large group of individuals that came from Puerto Rico, and they basically set up housing in Port Austin. I think there was some here in Bad Axe area. So Huron Transit was actually providing service to them from their homes to get to the casting plant here in Pigeon. And a very rural shuttle type of application. And I'll talk about some other options that we also looked at, but this is the complexity map. It's, most of it is just a 2-lane rural highway, speed limit's 55 miles per hour, just kind of, you're traveling straight. You get to maybe medium complexity when you're going through some of the smaller towns, but for the most part, it's easy to operate. One of the key things with this route is deer and farm equipment. So those are things that the automated bus has to be able to recognize as it's traveling this route. So Huron Transit also wanted to look at some alternative routes because they weren't sure if the transportation service for the steel plant workers was going to continue long term. So this option here basically utilized a good portion of the route we identified in the original concept, and it's going to provide a service for basically students that are going to go to a community college located in Saginaw. So it would do a pickup here at the North High School, go on Highway 53, basically is where Van Dyke Road is, and then do a drop off at the Bad Axe High School. And then from there, they'll just jump on a traditional diesel bus to get into Saginaw. And then longer term vision is actually to provide the service all the way to Saginaw here. And the cool thing is you could provide students to Saginaw, and there's also workers that live in Saginaw that go to the Blue Diamond Steel casting plant. So we figured we could make the trip with students and then make a trip with the employees. So we'll see how those pan out here in the coming months. I'm going to talk just about a few other examples. So Rochester, they basically are more of an, I guess, mixed freeway arterial type of service. So they have a park and ride lot here at the old IBM campus and another one here at a community college. The challenge they have is there's no parking for employees that work at the Mayo Clinic. So they're going to provide automated bus service from the parking lots. This is Trunk Highway 52, which will go into mixed freeway traffic. And then 2nd Street is basically arterial. The complexity here is these high-speed merges that have to happen on the freeways. You got, well, basically wherever there's a ramp, you've got high-speed traffic coming in. There's also a roundabout located here by the community college too, so that'll be interesting to see when we'll be able to get the automated bus to navigate that. Houston Metro, they are basically focusing on the I-10. It's the Katy Freeway operates here. So this is downtown Houston. There's a suburb city located over here. So the complexity here comes in where they get onto the freeway and they have to merge across 3 or 4 lanes to get into the hot lane. And so that becomes an issue, right? Potential issue. This segment here, you're in the hot lane. We have only one extreme complexity that came up on all our routes, and it was actually in Houston here. Let me back up. So Memorial City, there's a stop sign here, and the bus needs to make a right turn onto the freeway frontage road that the vehicles are traveling 55 miles per hour. And it's got to take up 2 lanes to make that turn. So that's an extreme condition we identified that most likely will be manual initially, and then we'll see if we can get there during the last stage of our program, which I'll talk about. Dallas is really providing service from a LRT station into the Love Field Airport. The biggest complexity here, it's arterial operations. You're going through some traffic signals, no big deal, but it's really when you get into the airport with all the different traffic and pedestrians and all the baggage activity. So I know there's some discussions about maybe there's a need to put a dedicated transit lane in that part of the airport to facilitate the automation. So that's kind of some examples of our pilots. I'll talk a little bit about the specification. So we've got it broken down really into 3 parts. APTA's been very active with our bus spec committee. So we actually leveraged their white book that they already had available as our base bus spec. And then they were working on an electrification piece of it, still kind of in draft form, but we took it into the spec, and bus spec committee went through it and made some revisions. We got rid of all the diesel related requirements and made it applicable to the ABC program. The new thing we had to create was this automated driving system piece. So as AACOM looked at this, we wondered, how should we approach this? Because if you think about all the complexities, right, the components of an automated vehicle, there's a lot here shown in this graphic. So this environment down here is really kind of that pilot or the roadway environment. So we decided we did not want to get prescriptive on all these different pieces of the sensors and communications and the command and control. So we thought, why don't we really focus on what this environment is? And as long as we can identify what that operational design domain is, and once we figured out what our pilot projects were, that really defined what we needed to operate in. So that ADS spec really turned into be more of a performance-based spec for the industry. And it's gone through several iterations since really the fall of last year. I mentioned the industry forum that was conducted in downtown Detroit last September. We had great participation, 120 individuals, 54 different companies. We had some one-on-ones. And so this has really been an interactive process with the industry. We've gone through several iterations of our spec. We've had recent discussions with some of the companies down here at the bottom. In early June, we met with New Flyer, Proterra, BYD, Nova Bus, and Arrival. And the Bus Spec Committee and Operations Planning Committee had an opportunity to talk one-on-one with them to see where they were at with the technology and what questions they had about the ABC program. Some of the things we heard from the industry is your schedule is really aggressive. You've got a lot going on that you're trying to accomplish, which really increases the complexity. Is there a way you can kind of phase this or stage it? So that was some of the input we got. Safety, of course, being number one. Whatever we do, we want to make sure it's safe, right? So we thought about the phasing and the staging, and this is what we came up with. We said, let's take this and split it out into 3 different stages. So when the buses get delivered to the agencies, they're going to have all the hardware they need. And then we want them to provide all the behaviors and functionality in stage 1. So a year later, we want them to do over-the-air software updates and give us the additional behaviors and functionality of stage 2. And a year after that, the same thing, and we would get the additional behaviors functionality for stage 3. It's really similar to the model Tesla is using with their vehicles. They provide you the vehicle and the hardware, and then they're doing the software updates to give you a higher level of sophistication with the automation. So that's kind of what we decided to do. Maybe I could point out some key differences between the stages. So when you get from stage 1 to stage 2, you're really having the ability to merge at a higher speed. So when you get to stage 3, you're going to have the ability to merge at speeds above 45 miles per hour. So that'll really take care of kind of the Katy Freeway and the Trunk Highway 52 example in Rochester. So that's our concept. This is still being revised and tweaked. We're trying to get input from the industry on what's realistic. The other thing we're going to do with our procurement package is ask the industry to tell us, based on what we're proposing for a pilot, what's the % of automation you could provide with the buses that are procured? And so it'll be interesting to see. We don't think we're necessarily going to get to 100% automation initially, and that's okay, right? But ultimately, we want to get to 100% automation with the more sophisticated software. So a little bit on the electric charging infrastructure. So kind of our base is the plug-in overnight charging, least expensive. It does take more time to charge. Some of the agencies, based on how they operate their routes, are looking at, kind of the conductive charging. It basically has that overhead connection. So that could be implemented along your route somewhere. Also inductive charging, which is the wireless. Not as efficient as the conductive, but you can have quicker charging times, or you could maybe have inductive charging set up in your depot for overnight charging. We're going to get more into details into the charging requirements as part of our Phase 2A part of the program. And I'm going to see if this works. This is a little sample of what's going on in Singapore. It's the Nanyang Technical University. There's music in the background, but you don't need to hear any audio on this. But this is an example of a full-size bus. It's on a confined, controlled route, operating at slow speeds, but it just gives you an example that the industry is working on this, so it is becoming a reality. There's an example of the overhead charging, the conductive charging. I like what they're doing is because they're looking at the interaction with the pedestrians and just showing how the sensor technology is able to detect and classify. So they're also going with the battery electric buses. So that was kind of a little example. I'll talk a little bit about what's coming up. So we're really wrapping up the phase one. We hope to get all the agency commitments by the end of next month. And then we're really going to go into the procurement phase. I will say that Michigan DOT, Jean Roostman and her group have stepped up and said, we want to be the procurement lead. So they're going to take the lead for the other automated bus consortium agencies in leading the bus procurement. And then each of the agencies would establish contracts for the number of buses they want to purchase individually with the bus manufacturer. So that's kind of how we see it playing. So we're really going to be, once we get phase 2A going, working on finalizing up the bus spec and the testing requirements and the procurement package, and then issuing the RFP. We're hoping we can still get that out by the end of the year. We'll see if COVID has any impact on that. And then the vendors would be preparing proposals. So, you know, maybe late summer, fall of next year is when we anticipate getting proposals and bids back from the bus manufacturers. And then we would be, well, actually, it's more summer of next year. I'm sorry. And then, you know, maybe fall of next year is when we would be looking for the another go, no go from each of the agencies on participating in the procurement. The buses are going to need some time to be manufactured. We got an 18-month window in there. We're hoping we can get a prototype bus in the first 4 or 5 months, and then we can actually do some national testing. You can see kind of the purple bars there. That actually goes along with the electric charging infrastructure that needs to be designed and built, and that will be handled individually by each agency because it varies widely from agency to agency. For example, Foothills Transit had been doing electric buses for over 10 years, but CATA and Huron Transit have no electric charging infrastructure. And then, so we'd be really looking at commencing service on the pilot in kind of the fall, early winter of 2023 is what our schedule looks like right now. COVID-19, right? It happened really after the formation of our consortium, but we do believe automated buses will offer some mitigation to the virus. Transit agencies have really been dealing with a lot. It's really impacted their service. At one point, their ridership was down over 90%. New York MTA, we all know New York got hit really hard, right? Their MTA drivers, they had over 100 deaths due to the COVID-19, so pretty devastating. So we talked about this at our last policy committee meeting on should we be thinking about some safety enhancements or retrofits for our spec that we're putting together, and everybody thought it'd be a good idea for the bus spec committee to really look at what should we do to protect the drivers and the passengers. There could be some really simple things that we do, like improving the ventilation and air filtration systems, maybe speccing out some UV lighting for disinfecting. We could consider maybe modifying seat arrangements, but maybe that's done individually by each agency to accommodate social distancing. But we'll be discussing this more in the coming months. This is actually some images we got from Atastec, and they're thinking already about how do you reconfigure the seating in a bus during a pandemic, and what would these plexiglass shielding units look like? So this is just an example. AECOM, our team actually has a meeting with another company next week, and they wanted to talk about some of the COVID-19 safety enhancements that they're working on for buses. So it'll be interesting to see what they're offering. And then we do have a website set up, automatedbusconsortium.com. So we've got information on the membership, the pilot routes, and just general info on the program. With that, I think I'm going to pause, Jeff, and we can see if there's any questions. And then if we have time, I can get into some of the Minnesota shuttle winter weather testing.
Excellent. Excellent. Thanks, Daryl. We will open it up for questions now. And I don't see anything in the chat, but feel free to take yourself off of mute and ask away. Daryl, I can kick us off with a question. Yeah. So I think you guys are doing great work here and have a initial group established that is working its way through this, making automated buses real. Curious on what the process then looks like for others to join as you make your way further and this becomes a reality. How would other transit agencies then participate if that's an option?
Yeah, that's a great question. So one of our late last year policy committee meetings, we initially went in thinking we were going to do one award, and then the policy committee said, you know what, it would be great if we could do multiple awards or maybe up to 3 vendors when we go through the procurement process. So we said, well, that's going to bring down our number of bus orders. So the policy committee actually asked us to go out and do some outreach to see if we could get other transit agencies interested in the program. So we have been doing that. We think we have maybe 2 or 3 other agencies that may have interest in joining. So we've learned a lot through the last year. So we think we can expedite the whole feasibility study part of the program. So if new agencies come in, we can get them caught up with the other agencies and get them included into the procurement that's going to happen. So I would say if you or anybody knows of other transit agencies that may have some interest, let us know and we can do a brief presentation to them about the program, see what questions they have. But yeah, there's an opportunity there right now to bring in new agencies.
Excellent. Other questions from the audience?
Daryl, this is Gary Petrovich with Oakland County Road Commission.
Yeah. Hey, Gary.
Hello. What an impressive project you have going on there. But obviously there's a lot of obvious savings from the consortium side of the world, but it was mentioned in the beginning about operational savings. And I was curious at how, as long as you still have a driver in the seat, where the operational savings will come from.
Yeah, that's a great question, and that gets asked pretty often. So initially, we still are going to have that driver on board. So that operational savings will be a wash. We're not going to see much, but once the technology is proven and reaches that level of sophistication we're comfortable with, you might want to change that driver position into an ambassador type of position, which then you could look at different pay scale rates. So you might be able to see some savings there. So it would be more customer focused and not having to worry about driving. When we get further down the road, when we can actually remove that person from the bus, that's when you realize the big savings. And maybe, like I mentioned earlier, that person goes into a control center, which has the ability to monitor and intercede if there's something going on. Actually, passengers would have the ability to communicate with somebody remotely. But you could have one individual managing, say, a dozen buses easily, right? And that's where some of the savings come in. For our initial assessment, we realize there's going to be some fuel savings, if you go from diesel buses to battery electric buses. But then we realized, well, you're going to be increasing your your charging needs. So for our initial analysis, we said, well, let's just call that a wash, you know, electric charging, utility rates versus the reduction in the fuel savings. So I don't know if that answers your question or not.
That's good. Thank you, Daryl.
Let's do that.
Other questions that might be out there?
You know, Jeff, what I might do, I don't know if Jean Roosman is still on, but I guess I would just ask Jean if she wanted to make any comment. Maybe I missed something that's important to Michigan, but Jean, if you're still on, you know, you're welcome to make a comment if you'd like.
Thanks, Daryl. I think you've covered it really well. I mean, we're just excited to be part of it and, you know, help the industry move forward. We're trying to approach it from a lot of different directions in our state. So this is just one of many. And it's really been helpful, the partnerships with, you know, AECOM and all of the other members. And I think that's what we want everyone to understand is that this is so much easier to do and makes so much more sense to do in partnership with other agencies. So we can really demonstrate all the different applications for a large AV. And we've also within Michigan partnered with other entities within the state. And I think it's been a really good model to follow. And I do hope others, you know, want to join down the road. That's kind of the purpose of it, is that, you know, we can open this up and get more people involved and start proving out how do we launch AV buses and how do we make sure that we get that proper mix of public-private partnerships. That's really important in this whole new ecosystem. So I think that's all I want to say. I think you did a good job, Daryl, covering it, and we're just excited to see it keep moving forward.
Thanks, Jean. Appreciate that.
All right, any other questions?
It looks like we've got about 7 minutes, Jeff. Maybe I can cruise through some of this MDOT AV shuttle pilot testing we did. Does that sound good?
I think it's a good idea. Go for it.
All right. So this actually occurred during 2017, 2018. And so AECOM was the consultant program manager supporting MDOT on the project, and we were actually working with another consultant as well. And MDOT really was looking at what was happening in the automated vehicle industry, and they said, you know, most of the tests and pilots that are going on are in these warm weather climate locations, and the weather is completely different in Minnesota. So you can see this picture here of the winter weather that we can experience, and how does an automated vehicle work in this? So that was MDOT's interest. Safety, number one, of course, right? So they had 380 fatalities in 2018. But they're really curious, you know, how does this automated vehicle stuff work in our winter weather climate? They know automated vehicles are coming because they could see what's going on around the country, and, you know, with the freight industry, and they feel transit is definitely going to be the first ones coming. They also tapped into a AAA survey that was done. It said like 3 out of 4 Americans are afraid of self-driving vehicles. So they said, you know, we should get this out there and start exposing it to the public. So that's kind of what drove their need to do the pilot. So the testing actually was at the Controlled Min-Road facility. It's about 35 miles northwest of downtown Minneapolis. The facility was set up in the early 1990s as a pavement research. So they got a bunch of sensors in the pavement, and they basically have this truck you can see in the picture. It goes around the track 8 hours a day, every day. By a driver, and that's actually a great automated vehicle application right there. But you can see kind of in the middle here, there's the loop here. It's identical on the other end. It's 2.5 miles. This is a 3.5 mile stretch of I-94, which is a bypass that they use for testing. And this is Interstate I-94 right here, the 2 lanes on the right. So we had a very low speed AV shuttle. So we said we don't need to use the 2.5 mile closed loop. So we used a portion of it. We ended up about, 0.8 miles in length. So that's the route that got programmed. When we started, we created a demonstration plan. We wanted to do all our scenarios under clear weather conditions as a baseline, and then we would move into winter weather types of conditions and testing. It didn't work out that way because we couldn't control the weather. So it was really a mix of everything in there, but in the end, it all worked out. You can see on the box on the right, the examples of what we tried to introduce in the various scenarios that we looked at. MDOT hired Easy Mile. They used their first gen Easy 10 shuttle, level 4 automation. The only detection on the vehicle was LiDAR. They had 8 LiDAR sensors. The max speed we got at testing was a little over 11 miles per hour. We had the ability to vary the speed depending on what we were doing. And little clip on one day we were at Monroe, very cold, snowing, windy. This kind of shows some of the conditions that we had to deal with. So I'll share some of the findings. Whether it was bare pavement or a slight 1-inch snow, performed well. Very little issues. We were pretty happy to see that. The biggest issue was the loose and the blowing snow on the road. The LiDAR basically picks it up as an obstruction. It doesn't know if it's a ped, another car, or snowflakes. So that was the biggest shortfall of the technology. This is a housing showing how the snow actually started accumulating where the LiDAR sensors were located. So as the vehicle moved, the snow started blowing around and was actually being picked up as an obstruction. So it would stop the vehicle. So that was something that we learned. The wheel wander accuracy, 3 millimeters to 1 centimeter was great. And you can kind of see some examples here along our path where it was very obvious. Performed well in ice. We created ice patches. It was four-wheel drive vehicle. That was not an issue for the localization. We tried road salt. That had very little impact on our findings. Slush, we were driving through snow. If it got too deep, we would get stuck. But for the most part, it was able to navigate through. This is a snow making machine that created a snow cloud for us on one of our very cold days. And we just wanted to see how far the shuttle would actually make it through the cloud before it came to a stop. So when we got to it, we slowed down, and ultimately we ended up in an emergency stop situation because the sensors just didn't know what was going on. This here actually shows the snow making machine. We actually rented it from a nearby ski hill and had it out there for a few days. So we actually sat, and we told the guys, can you shut the snowblower down? And they did. And once the snow settled down, the vehicle was able to recover and then proceed along the path. I don't have a video of that, unfortunately. This is Mike Kronzer, the MDOT project manager. He's filming. He's actually passing us. We're in the AV shuttle. And it was fine, good interaction with the car, no issues. And then the vehicle started slowing down and we couldn't figure out why. It was a very cold, bright, clear day, no snow, no wind, but look you can see the exhaust. So the sensors were picking up the exhaust as an obstruction, didn't know what it was, and it actually stopped us. So that was a lesson learned. So we did a lot with, we started with obstacles, cones, barrels. When we were comfortable, we introduced pedestrians. That's Mike Kronzer again. But we were doing these at pretty slow speed. We did find that if we increased the speed, it did increase the stopping distance from the person. And we had a mild day. We were able to do some things with bikes. Very similar to pedestrian interaction. So this is Ben, who was another MDOT employee working on the project. Sigh of relief. We did testing. We had a variety of everything. in the 40s, I think minus 24. Wind chills was the coldest day we were out there. Mornings, nights, different daylight conditions. We wanted to test everything. MDOT pulled their car in front of our path. We knew it was going to stop, but that was one of our tests. We also took a lot of battery measurements during the testing. We found on the really cold days it basically reduced the capacity and range in half. So instead of getting, let's say 14 to 16 hours, we dropped to 7 to 8 hours max. And even below that on some really cold days where the heater was running a lot and we were using the mobility ramp for demos. MDOT did do a lot of demonstrations to the public to help the exposure. A big one was the Super Bowl demonstrations in downtown Minneapolis in 2018. You can see some of the comments. We got, hurry up, get these things in our city. We can't wait for the future. So we heard a lot of positive things from the public. And we had a group, this is the state chapter of the Minnesota Federation of the Blind. They came out one day, rode the shuttle, and really excited about the technology and how it's going to improve their quality of life. They gave us some really good input too on the vehicle. So if you're interested, we do have a final report you can find at MnDOT's website. So you can go check that out. And MnDOT is proceeding with a couple other shuttle pilots. The difference here will be these will be implemented in mixed traffic situations. So more on that will come next year. Maybe I'll stop right there, Jeff. I know we exceeded noon by a couple minutes, so we could probably wrap it up.
Yeah, thanks, Daryl. Thanks for joining us today and presenting on the Automated Bus Consortium. I think you guys have a great project there, and best of luck as you move it through phase 2, and look forward to a future update to the group here as you guys continue to make progress.
Well,
also
thanks.
like to thank everyone for joining today for the ITS Michigan webinar, and was going to make one last plug. So we do have the next webinar scheduled for August 13th. So if you go to the ITS Michigan website, you can go ahead and get registered. They're free, and we'll be on Thursday, August 13th. So with that, we'll conclude today. And thanks again, Daryl. Best of luck as you guys move forward.
Thank you. Appreciate it, Jeff.
Thanks.
Yep. Bye, everybody.